Hi everyone, my name is Engku Adlina and today I would like to share about Infimum and Supremum. We are going to focus on the definition, some examples and the completeness axiom in the context of real numbers. Before that, let's look back at the definition of lower bound and upper bound and suppose S is a subset of real numbers. W is a lower bound of S if for all x in S, there exists W such that x is greater than or equal to W. On the other hand, U is an upper bound of S if for all x in S, there exists U such that x is smaller than or equal to U. Okay, that's what we already know. Then, do you know what is infimum and supremum? Well, infimum is the greatest lower bound, while supremum is the least upper bound. Notice that lower bound or upper bound are not singular. Instead, they are a collection of infinite numbers. So, among all the lower bounds, the greatest one is called infimum, and among all the upper bounds, the least one is called supremum. Now let me illustrate a few examples here to give you the idea of how infimum and supremum actually work. The first one is, let's say, S is a half-closed interval from -5 to 24. This is how it looks like if you transfer it on the real number line. Then there are many lower bounds such as -9, -20, or maybe -100, but the greatest one is -5. So inf of S is -5. Same goes to the upper bound. We may take 25, 84, or 120. They are all upper bounds as long as they are greater than all the elements of the set. However, the least upper bound is 24. That's why sup of S is 24. For the second example, S is defined like this. If we do some simple algebraic manipulation, we will get that x is greater than or equal to -5 and x is less than or equal to 2. This is how it looks like if you transfer it on the real number line. Like the first example, there are many lower bounds and upper bounds, but we take the greatest lower bound, which is -5, as the inf of S, while the least upper bound, which is 2, as the sup of S. And for this set, both inf and sup are in the set of S. This is because S is a closed interval. And the last one, if we apply the same technique, we can clearly see that inf of S equals to -√13, while sup of S equals to √13. This is how it looks like if you transfer it on the real number line. But this time, both inf and sup are not in the set of S. And again, this is because S is an open interval. So these are the examples of non-empty real number sets which are bounded above and bounded below. Now let's move on to the last thing, which is the completeness axiom. This axiom stated that every non-empty set S subset real number with an upper bound has a least upper bound. We have to understand that this does not mean that every subset of real number has a least upper bound. It just means that if a set have an upper bound, then it has a least upper bound. So let's take a look at this example. The set indicates that for all rational numbers, the square of it is less than or equal to 2. So we can imply that sup of S equals to the square root of 2. However, if we are considering rational number as the universe, then we have to say that this is incomplete as the square root of 2 is irrational. So the set does not have a least upper bound. Alright? So I hope you understand my explanation well, and I think that's all for today. Thank you for watching.